The aim of this short practical is to show you how you can use Excel to separate out a list of values based on categorical lines such as diseased, not diseased, gender, and so on. And you can use this for stages of disease as well. So typically coding would be used for gender or smoking, non-smoking, for example, and other similar categorical variables. So in this case I have male is equal to 0 and female is equal to 1. So anytime you see a 1 in a row, that means those values are coming from a male or from a female, and anytime you see a 0, that's coming from a male. So what we'd like to do is actually split up the data. So I have a series of data that is just males and a series that's just females. Now that's one way that you can actually do it and make it available for you for further analysis later on, such as doing a male and female specific scatter plot. You can, if you want, just write a formula to give you the averages based on males only, but we're not going to worry about that today. So to do this kind of splitting of male and females, you're going to need 2 extra columns, so someplace for the data to go. And that really is the glucose male and glucose female column that you can see here. So to get the glucose in males only, so remember that's just 0, so we need to use a logical formula in Excel, and that's an if. So what we're going to tell Excel is if B3, so this cell, so B is the gender column, so if row number 3, which corresponds to the value, if that's equal to 0, show me the value for males. If it equals anything other than a 0, I don't want to see it. I don't want anything in it. So I want an NA, not applicable type result. So if B3, which is now highlighted in the dotted lines, equals 0, so that's the test. So if that test is true, I'm going to want to see C3, okay, which is the value for glucose in that male. And if it's not true, I don't want to see anything. Okay, so I'm going to use NA and brackets. And that's just a way for Excel to give you essentially what it'll be like an error message, but it will be a fully ignored value. So if I hit enter now, you'll see I have 8.72, and it's checking if the blue box in B3 is equal to a 0, then it shows me what's in the screen box. And I can apply that to all of my samples the whole way down. Okay, so now I have values for some, which are the males, and I have NAs for the females. So we can do essentially exactly the same for females now. So it's if B3 equals 1 in this case, so we're saying if it's female, show me the value, and if it's not female, give me the NA instead. When I hit return now, of course I get an NA, and I want to send this formula down to the bottom, so I can double click on the little box. So that goes to the bottom of my data. So yeah, it maybe looks a little bit messy with the NAs, but the NAs are useful later on because it will allow us to do a correlation curve very, very easily, or a scatter plot at least, not necessarily correlation with these data. So because we've put in the NAs, averaging is going to take a slightly more difficult turn. So normally to get an average, we would just use the average formula, which is equals average and then pick the data range. In this case, it's going to be C2 to C72. Okay, well actually it's C3. So if we try and use that formula in the other cells, we'll get an error message, which is NA, because it's trying to incorporate those NAs. So we need to tell Excel to ignore those. So one way we can do that is to go in and manually delete them all, but that kind of defeats the purpose of what we're trying to do. You can absolutely do a find and replace. There's no problem to do that. But you can also just get around it by getting Excel to do that kind of work for you. So what we'll do is average, and we'll use average if. So we'll actually set a condition for the average. So this is going to be D3 all the way to D72. So that's our range. Our criteria are we don't want it to have the text that we can see. So we want a not equal to symbol. So that's 2 angle brackets. And then we put in not equal to this precise text that we're trying to avoid. So that's NA. Okay, so that basically means average everything that's in that column of data, but ignore those bits that I'm not interested in, which is the text, the NA bits. So once we've got that separation done, we can then look at calculating averages for the different types of data. Now we want to get an average for all of the male and an average for all of the female. So the key point here is to make sure that we can do that sensibly and easily within Excel. So typically to do an average of anything, you would put in the formula average, AVE, and then select your data range. Here we're in row C, so it's C3 to C72. So that will capture all of our data. And then our average is 8.1. Now if I try and apply that to our selected or our screened data, it doesn't work because we have this not applicable symbol. So one way to get around that is to do a removal of all of these using a global find and replace or something like that. But there's also another way to do it. And that other way to do it is to get Excel to only average if it meets conditions we set. So average if. So we're going to take an average from the D column, so D3 to D72, and we're going to set criteria now. So we've set the range, and our criteria is going to be using pointy brackets. We're going to say basically not equal to what's going to follow. And because NA is a text, we're going to use inverted commas around this whole set. So we have the hashtag, then the N and an A, so it looks exactly the same. And then I'm going to put the rest of the inverted commas around that and close it. So when I hit return now, we should get a number instead of an NA. So there you can see 7.8. If I drag that across, you can see I get an 8.4. So I have the value for the male and the value for the female. Now, the reason we're going through all of this hassle to do all of this is because we want to be able to go to the next step, and that's to do a correlation on the same chart for male and female glucose with cholesterol. So let's just unhide some of the columns, and you can see these ones are blank. Now that's because the formula is slightly different, and the reason I'm showing you this formula is because it achieves the same effect from the point of view of the table, but it doesn't work when you try and graph it. You'll get a lot of null values, so it won't work, because even though those cells look blank, they still contain that formula. So we need to port over our more advanced formula with the NA. So let's just pop that in, okay? So if you can see, remember it was NA brackets, so we'll just stick in the NA brackets. Again, we'll just drag this right down to the bottom. And just like before, we can apply exactly the same formula. And the thing is, with the average if formula, if there's no NAs, it looks exactly the same. So now we're kind of ready maybe to do a little bit of graphing on this data. So I want to have the glucose of males and females versus the cholesterol of males and females all on the same chart. Okay, because I think it would be useful to have the full population spread shown and also the males and females. So let's start off doing the males. So I'm going to highlight all of the male data, and now I'm going to highlight all of the male data for cholesterol. And what we want to do next is go to insert and pick a scatter plot, and we're going to have scatter with only markers because we just want the dots, we don't want them joined up. And there we go. Very quickly you can see that we actually get a scatter plot of the males. Now, knowing what we have from our data display tutorials, we can clean this up a little bit and get rid of some of the stuff we're not interested in. So very quickly then we actually see that we have a reasonably good scatter plot. Now you'll notice the axes don't have labels on them. And that is something that you might want to consider going through this in more detail. But we'll just work through adding in the female dataset first, and then once you've got that added in, you can always then adjust the formatting of the axes a little bit later on. So now what we need to do is go to select data, and this allows us to add a new dataset. Okay, so what I'm going to do is I'm going to add, and this series name, I'm just going to call it female. So for the X values, I'm going to pick my glucose again because that's what I had previously. Oh no, we're still in male. Sorry, excuse me. We need to go to female for that. So I'm going to pick my female. And then for my Y values, I'll pick the female cholesterol values. So now we'll have both genders graphed so that we can see them separately. So you can see there's female and male. And I hit OK. Let's go back up. Now we have males and females on the same one. So you can actually then do a little bit of tweaking and editing of this. But now you can see you can have the entire population. And if I want to, I can actually then put in a trend line for each population. So I'm just going to very quickly stick in one for male and female, and you can see that they're pretty close. There's not really any great difference in them, but the advantage of this type of approach with the NAs and with the little bit of extra legwork is that it allows you then to capture everything very quickly in one place. Now from a data formatting point of view, very quickly what I would suggest with your markers, I typically prefer to go with round. And in this case, I would probably change the color. So we're going to change the color of these guys into sort of a medium dark gray. And you'll notice the line around it is red. But you'll also notice that in some cases, particularly here, you have overlapping data points. So I would typically suggest for the marker line color to make that white. So now it reveals the overlapping ones. For the male ones, I would again look at having the marker options using the same symbol is fine. You don't have to use a different symbol. I would change the color of the marker in this case. So I'm going to make it black. So I'm going to have black. I could certainly have white with a circle around it either. That's fine because then it's very clear what you've got. And I'm going to change the marker line color again to white because I like that idea of having white. Now, just looking at it, the gray maybe could be a little bit better. So what I'm going to do is pick a slightly lighter gray so that it's definitely distinct with the males and females. Few other little things that we'll just do quickly to tidy up. We don't need any decimal places because we have a very straightforward type of number series that we're showing. So think about it. You have your cholesterol and your glucose. It's not going to be very high, so it's fine to have it without. But from a layout point of view, we're going to want axis titles. Whoops, I want to rotate a title. And then you can actually put in the results that you want. Okay? So then, once you put in your titles, you effectively have a scatter plot that shows the entire population and gives you the option then to distinguish between the male and female populations. And you can obviously make this a bit more sophisticated if you choose to do that.